Hi, welcome to this video presentation. This is Dr. Anbu Selvan. So in this video presentation, I'll be explaining, all right, some of the important diagrams, essential diagrams, all right, that are actually needed for system development, right? So basically, when it comes to stage of system analysis design, all right, in SDLC, right, definitely, right, you cannot run away from creating diagrams, right? So we need to know the essential diagrams, right, that are actually needed, right, for system development. So based on my experience in the past, actually, I've observed that many actually students in the higher educational institutions, right, they are not really knowing, right, the kind of diagrams that are actually needed, or not very sure, right, the important diagrams, right, that needed in the report, okay, that are actually needed to be built, all right, when it comes to actually, right, developing an application, all right. So I'm going to actually give a clear picture, right, of diagrams that are actually needed, okay, for system development. So basically, right, we look into two techniques, all right. So the first technique is actually, right, we call it structured programming technique, right. Example like C language, C++, all right. Definitely, right, they actually come under the structured programming, okay, like Java, okay, C sharp, okay, those programming languages, right, uh, fall under this category. We call it object oriented, right, programming languages, right. So for if you are going for C language or C++, right, to develop an application, okay, then there are certain diagrams actually associated with this structured programming technique, right. While object-oriented programming technique, right, definitely you have to comply with UML diagrams, all right. And of course, when you talk about UML diagrams, there are plenty of diagrams, right? But I'm going to talk about essential diagrams, right? That are compulsory, that need to be developed, right, or built, all right. Of course, it is good, right, that you can actually build all the UML diagrams, but for certain cases, all right, if you're doing a system that is not too complex, all right, or not sophisticated, all right, then we can just go for essential diagrams, right. Okay, so after, right, observing this video presentation, right, you will have a clear picture, right, okay, what kind of diagrams that actually you have to develop, all right. And this is based on um, technique that you're going to actually use, all right. When talk about Python, like certain programming languages, right, of course, like Python, right, you can actually use structured way, or you can actually use object oriented way, right. So it purely actually, right, depends on the, the nature of the project, or nature of the, requirements, okay, and the preference, all right, of developers, right. So it depends, all right, the kind of actually programming technique they're actually going to use, right. So I'm going to start with structured programming, right. So let's say you have chosen Python as a choice, right, for your system development, right, application. It can be a web-based application, or it can be a desktop application, or it can be a web services, whatever, right. So the fundamental is still the same, all right. So you have to choose, all right, whether you're going to go for structured programming technique, or you're going to go for object-oriented programming technique. Okay, so in the case of structured programming technique, right? Okay, so usually, right, I think all of us know, right, the use case diagram, right? So use case diagram mainly, right, is created for the object oriented, all right, programming technique, okay. So is one of the most important diagrams, right, in the UML, okay. Now the purpose of the use case diagram, right, to know exactly what the system actually offers, all right. So I will say that, all right, based on my experience, the use case diagram, right, can be used, or I would say is important to be demonstrated, right, regardless of the technique they're actually using, right. Of course, object-oriented programming, all right, technique, if you're using that, definitely you cannot run away from use case, right. Even for structured, you can actually come up with a use case, right, because basically use case, right, is important not only for developers or programmers, it's also important for the client, your client actually, right, who is actually funding your application or sponsoring your application, right. Okay, so they would like to know, right, the kind of functions, right, that actually the system actually offers, right. So I would say use case diagram is something, a general kind of a diagram, right, that is important, very important, right, to demonstrate the functionalities or the features, all right, or the functions, all right, of a particular system, right. So let's go into this. Let's look at this use case diagram, right. So this is just an example. So let's look at this particular. This is actually is a use case diagram, right. So by right, you'll have a boundary, something like that. You should have a boundary, okay. And on the left hand side, all right, all of them actually actors, okay. On the right hand side also actors. So normally, right, on the right hand side, right, you may have a situation in which, all right, system, right, external system actually may be interacting with your current system. So your current system, the boundary, right, starts from here, okay, and then it's like a box, right. So whatever that is outside is actually, we call it actor. Actor can come in the form of human or system. Like this one, accounting system, right, is a system that is actually interfacing with your system. All right. Now, if you look at here, right, there are various types of actors, right? Okay, and you can apply the generalization concept here. Okay, so you may have maybe a user. User is like very general. Under the user, you may have a more specialized users. You can actually apply generalization, right? So the generalization can be applied right to actors, can also be applied to use cases as well. Now, this is actually, I will say, business use cases, or we call it core use cases, right? We are just highlighting the important use cases, so we call it business use cases. These are the actually use cases that are actually very important for client, all right? Because end of the day, right, they want to know what the system can offer, right? And we call it business use cases, all this. Besides the business use cases or core use cases, we also have supporting use cases. These supporting use cases, right, is actually came into being, right, as a result of, when you have the relationship extend include, right. So extend use cases or include use cases are those actually, right, we call it supporting use cases, all right, supporting the business use cases, all right. Now here we don't get to see include, extend use cases, because we have the option, right, to hide them actually, because end of the day, right, the use case diagram, right, must be readable, simple, easily, right, understood by a user, right. So if you're going to put, like, a lot of include, extend, right, so this is going to actually, right, confuse the users, right, and you may actually face rejection, right. Okay, what do you call, to develop a system, right. Okay, so you need to show the client, right, okay, these are the main use cases, business use cases, all right. So they're actually only interested, right, in knowing, right, the main use cases, right, or we call it business use cases. Extend, include, right, may not be interest, all right, may not be interest to customers or end users, because those are actually supporting use cases, right. So they're actually, those use cases, right, will be important for developers, programmers, okay. So you can actually have extend, include, you can have, but you have the option not to actually show up here, right. So if you think your system is like very simple, you don't have a lot of extend, include, then you can actually add here extend, include, no issues, right. A rule of thumb, a good practice, right, is you try to have business use cases, right, in one particular use case diagram, all right, within the box, right, system, 8 to 10 use cases, all right. Okay, so if we have more than 8, 10 use cases, then we try to actually write separate. Maybe you have another use case diagram. Okay, so always we need to know, right? When it comes to use case diagram, is also right. The diagram is intended for end users as well. All right. So you always have to make sure, right, your use case diagram is simple, readable, all right, and interpretable, right? Because you have to show this to your client. Okay. So that should be in your mind. Okay. So having done that, once you have done this, right, so now we know, right, at this stage, right, we know that, okay, the system actually, right, can do this and that, right, maintain orders, maintain inventory and so on, right. So let's look at here the maintain thing, right. Maintain here, right, is actually covers CRUD operations, right, add, update, delete, read and all those things, right. So instead of having like add a separate, delete separate, read and so on, right, we just have to put maintain. That's it. All right. So this actually like um, a very general kind of um, use case. All right, where it covers. All right. If you dive into this, then this maintain, right, can be further divided into add, update, delete, those kind of things. Right. The next thing is the naming convention use case, right? So it always starts with a verb, okay? Or always starts with a verb, all right? Maintain, active verb, process, all right? Generate, ship, maintain, all right? And followed by nouns, okay? So you have verb followed by noun. In some cases, you may have like three words, right? So we try to maintain, right, the number of words, right, descriptive, short and so on, right. So don't have like 4 or 5, right. I will say maximum 3, right, like maintain orders, that's it. This is 2, right. So you need to be very specific. All right. The use case name, right, maintain inventory, that's it. Must be very clear as well. All right, descriptive, short, precise. Okay, and then the arrow also we need to observe, right? Okay, for in extend include, right? You may have different symbols and so on, right? So observing, all right, complying with the notations are very important. Okay, in use case diagram, right? Okay, the arrows and all those things. Okay, now right now, right, we know that, okay, a system can offer this kind of things, right? All these functions, right? But we will not know, right, what actually happening within each use case. So you know what are the things, right, that a particular system actually can offer by looking at this, right? But we will not know, right, how, right, a system actually, right, executes or accomplish this task, right, or carry out this particular maintain order. So in order to know, right, what exactly is actually happening inside, that will be the next stage, right? So you have happy path, alternate path, exception path, right? Happy path, right, or we call it basic flow, right, is a sequence of steps, okay, that will lead to uh, what do you call normal execution, right? Means that successful execution, right? So just like when you go to ATM machine, right, you know you will you'll be asked to provide, okay, card, all right, you have to insert a card. After that, you have to provide your credentials. Then you want to withdraw, all right, then you have to like click certain menus. After that, eventually, right, you get what you wanted for, right, the cash and everything, right. So it's basically happy, right, because you don't get into any problems, right. So the transaction is successful, right. So that's what you call happy path, okay, or basic flow, right. But in some cases, right, not all the time, right, your transaction can be successful, right? Sometimes when you provide or when you insert a card, okay, the card may not be actually working, all right, due to some reasons, or maybe the reader, ATM reader, right, is so sensitive, all right, that that may not able to read your card. Okay, your card may be got spoiled, okay, or exposed to certain what do you call temperature, whatever things, right, that actually resulted in the card may not be able to use, right. There's so many reasons, right. Or sometimes you have other situations as well, right. You provide the credentials for some reason, right. Your username, all right, may not be authenticated successfully, all right. A lot of things can go wrong in the real world, right. Okay. Or maybe, all right, you will actually provide everything successful authentication, but you may be actually right want to cancel any transactions right away, right? And the system has to respond. Now, the things that can go wrong in the real world, right? Many things, right? So you got to figure out what are the things can go wrong in the real world, right? So if you don't think in that way, right, when something bad thing actually happens or unpleasant thing happens, right, the system actually can crash. So that is why we have the alternate path or exception path. So happy path is just only one, okay. Alternate path, right? They can have more than one, right? So alternate path or alternate flow, right? You can have more than one situation, right? Okay. So why we call it alternate path, alternate flow, right? Because these are the situations, right, that sometimes can take place. So, right, like if you look at here, right, a customer calls to change a product quantity for one order item on an order, right? So this one sometimes, all right, the client will do that. A customer calls to cancel an order. This is sometimes, okay, not always, sometimes, right? When you see exception flow or exception pathway, right, this is super rare, right? So very rare the customer will call to cancel an order that can't be found in the system. So there is a difference between exception path, alternate path, right? Alternate path sometimes, exception path super rare, all right? This kind of situation will take place, okay? So when it comes to a real development, right? So what we do, right? We come up with a kind of table here, and we come up with a use case name here, and then we start actually writing here, give a description, right, what happy path is. All right, this is a successful transaction. Alternate flow, right, you may have a first situation, second situation, third, and so on, right? All right, you just have to list lah, all right. And then for exception path, all right, you may have like here three situations, number one, number two, number three, right? The same thing you have to actually apply to all other use cases. But you may have a situation like, you may not have exception path for this kind of generate invoice. You only have alternate path. It's possible, right? But what is more important is we need to actually, right, um, find out all kind of possibilities that actually can go wrong, all right? So you have to think from the perspective of the users, all right? So that's very important, right? So why actually I'm saying this, because end of the day, right, your system um, must be good in the sense that, anything that actually happens, all right, unpleasant things happens, all right, the system must be able to respond, all right, okay, able to respond to situations, all right. So just imagine that if, let's say, your card, all right, um, let's say can't be read, okay, the system actually, right, if you go to the ATM, it will sort of like respond to that kind of situation, right? Okay, so maybe you'll like say that, okay, your system will be, a card will be rejected and so on, okay, and then maybe a signal will be sent to the bank officer and so on. So some or other, okay, when something happens, bad thing happens, right, okay, the system must be able to respond, all right. So that is very important, right? So how to actually translate all this into codes, right? So first of all, we need to identify the situations, all right? These are the situations, and later on, we will translate into codes, okay? So you will take a different path, right? So a happy path is a successful transactions. When something goes wrong, right, the system will take a different path to respond to a user actually. So once you have actually come up with all this, okay, identification of alternate path, exception path, happy path, and so on, right? So the next thing is you have use case specification. So we need to actually write uh, we have to actually explain in detail, right, happy path, right, what are the steps, all right, step number one, step number two, right, leading to successful transaction, all right. If let's say this situation, right, what will be the steps, how the system will respond, what are the steps, right, that actually the system will respond to this kind of situation, right? So that you have to actually provide the details. So I'm just going to give you an example here, right? If you're going for use case specification, okay, so let's look at here process orders, right? So we need to come up with like precondition, post-condition, primary, happy path. Happy path there's only one, or you call it primary. Alternate path you have, exception path you have. Next we have to detail out, right? Okay, for the happy path process orders, right? What is the first step? Step number one, step number two, step number three, four, and right? That's it, all right? So when you complete everything, right, you have a successful transaction, right? Now, What about for the alternate path? You also have to do the similar kind of thing. This is for the happy path. Okay, so for alternate path, then you may have step number one, step number two, or sometimes what you do, right, we will try to embed into this, all right? So end of the day, right, if this kind of situation actually happens, all right, the system must be able to take a different divert, all right, or will change the flow, right, of a normal sequence, okay, and then will respond, all right, will take appropriate actions and then respond to the users, okay. So you have to do also for the exception part. So you have well-defined steps, all right, for the alternate path. These are the situations, and also for the exceptions, okay. Now, if you think that, okay, this is in the form of words, right? Correct. Now, you're writing down all the steps, number one, number two, number three, and so on, right? We can also write, use activity diagram, okay, to demonstrate all this. And this is in the form of words. We can use symbols like activity diagram, right, to show the happy path, right? So you have options. Either you can go for the form of words or you can go for activity diagram. Next is actually, right, for each use case that you have, each use case that you have, maintain orders, okay, process orders, minimum there should be one activity diagram, okay. So let's say you're going for activity diagram lah, to describe what actually happening inside. So what you can do, right, for every use case diagram there should have minimum one activity diagram. So one use case, one activity diagram. So in that activity diagram, right, you will have everything: happy path, alternate path, all the alternate paths, and then all the exception path, okay. This is the minimum. In some cases, right, if your system is like too complex in the sense that you have a lot of alternate paths, you have a lot of exception paths, what we do, right, one use case you can have um, three three activity diagrams. One activity diagram to show the happy path, another activity diagram, right, to show the alternate path, another activity diagram, right, to show the exception path, okay. So it depends, right, but minimum you need to have one. So if you have like 10 use cases, then you must have 10 activity diagrams. Each activity diagram is associated with particular use case, right? So that is the thing, right? Okay, that you we need to do, right? That's a proper way of doing it. Okay, now once we have done the use case, everything is done, okay. um, Next, okay, so if you are going for object oriented, right, so object oriented, right, so we start with a use case diagram, okay, and do all this, okay. But if you're going for structured, right, so probably we just stop here, right, enough, all right. We just look at the use case diagram enough, right, so you don't have to go probably beyond this, right, okay. All those things, okay. So this is for the object oriented, okay, technique, right. So we start with the use case diagram and then we start actually identifying all this and then use case specification or activity diagram, okay. Now for structured, right, once you have done the use case diagram, the basic, okay, next what you have to do is you have to do the DFD, okay. So I'm actually explaining this, right, if let's say you have chosen structured programming, all right. Okay, so DFD, right, you have uh, something like this. This is how a DFD will look like. Basically, the DFD, right, you have several levels. Okay, so I'm going to show you that. So the first level is, we call it context diagram, right? This is actually at the highest level, the abstract, right? You just show the entities and then you have the process, okay? And then we try to actually dive deeper, okay? So from here, we can actually break it down, right, into several processes. So you have all those things, but you have to maintain the consistency, right? And then all this entity A, entity B, show the relationships. Level one, right, if you think that then this process, right, has a lot of things that need to be done, we further actually refine this process, right? Then you have 2.1, 2.2, and all those things, right? And then if you think that, okay, 2.2, right, has a lot of things, then we try to refine further. So you can have level 1, level 2, and so on, depending on the amount of tasks that a particular process has to carry out. Okay, so generally you have context diagram, level 0. These are the compulsory that you have to do, context and level 0. This one depends, all right? Now, once we have done all this DFD, so basically DFD actually shows the processes, okay? Once you have done this, then you have to actually map to, or you have to map to another diagram, right? So this, all this actually some examples. So we call it structure chart. So you have to convert the DFD into structure chart. So structure chart, right, will look like something like this. Okay, so this is your data flow diagram. Then you have to do like this structure chart, right? Yeah, this one. Okay, so the parameters actually being passed to here and so on, right? So this is a structure chart, so you have to convert the DFT into structure chart. So there are actually certain standard ways, right, to convert, or we call it mapping from DFT to structure chart. You can actually use some techniques here, right? We have here transaction structure, okay, and then you have transform structure. All right, so when you use these two techniques, then you'll be able to convert DFT into structure chart. Okay, so this is some guidelines, right? Okay, on how to actually write build structure chart. Okay, so your entire DFD, right, will be converted into structure chart. All right, so that's the thing. Once you have done the structure chart, okay, for example, like this, right? So a system may have something like this, the root, and then under that you have a lot of sub modules, okay, okay, and so on, right? So once you have done this, next is the program specification. So by looking at this structure chart, right, okay, we will know, right, okay, this box is doing something and so on, right, but we will not know exactly what actually happening inside. So that's where actually, right, the program specification comes into picture, right? So program specification, you have to actually describe what exactly happening in each box. Okay, so you can use CDO code, all right, something like that, CDO code, all right. So after this this kind of process, right, this kind of task, next will be the we convert each line, right, into codes. That's it. All right, so that will actually complete the entire process for the structured programming technique. Okay, after doing the CDO code, then you have to translate lah, all right, each line of CDO code, right, into appropriate codes. Okay, now what about object oriented? Okay, so if let's say you have chosen object oriented, then we start with use case specification and all those things, all right? All this, we need to do. Okay, a use case specification, we can go for words or activity diagram. So once you have done the activity diagram, everything complete, next is the class diagram. Class diagram got two types. One is the analysis class diagram. The other one is actually design class diagram. Many people write they do not know, right, the existence of design class diagram. Okay, so I've seen in many institutions, okay, even lecturers or students, right, they do not know, right, the existence of design class diagram, that is existence of design class diagram. That's very important. Without design class diagram you cannot develop an application, right? So there are two types of class diagram. The first class diagram that I would like to explain is analysis class diagram. Remember, we do ERD diagram, right? Entity relationship diagram, right? That is for the database, all right? So we show the kind of data that actually we want to store, right? So before, right, you do the ERD, right, we will create analysis class diagram. So basically analysis class diagram is meant for ERD actually. All right, so let's say you have in the ERD, right, user. So in your analysis class diagram you also have user. Okay, so we will map the analysis class diagram to the ERD. All right, so I'm going to show you here. Let me pick it up, this design class. Okay, all right, so I'll show you how analysis class diagram will look like. Okay, yeah, all right, so you have something like this. I'll show you. Yeah, all right, so we may want to store information of a patient. You have country, phones, address, and all those things, right? So these are the information that we want to store, right? So we actually do it in the form of class diagram, right? So this one we call it domain classes or entity classes, all right? Because these are the classes actually responsible to store information. So in this class, right, you only have attributes, getters and setters. That's all. Getters, setters, constructors. That's all, right? So it comes like a Pojo class or something like that, where it only stores information, getters, setters. That's all right? And of course, you will apply all these techniques, aggregation, composition, association, and so on. Okay, this is how an analysis class diagram will look like. You have attributes and then getters, setters, right? So these are the classes you have, and you have to show, importantly, you have to show the relationship. The relationship name is very important. UML notations very important, all right? So this is the analysis class diagram, we call it, all right? This is analysis class diagram. So you have to show relationship name, relationship types, and so on, right? Cardinalities and so on, right? And obviously, right, you need to have attributes and getters, setters, that's all. Okay, so this is important for ERD, right? Okay, so next I'm going to show you, right, how a design class diagram will look like. Now before that, right, we just take a look at this, right? This is what I mentioned just now. Medical staff, right? This is very general. This nurse and doctor is more specific, all right? This is more specific. So we're actually kind of applying generalization, right? So you look at here, this is the, we call it parent, this is the child, okay, and this is include and everything. This is actually the parent and the child. So you have the parent use case, this is actually the child use case. So we're actually using this notation. This actually indicates generalization. Okay, so record blood test, record medical service, you can have that, all right, no issues. Generalization. Okay, now let's look at the design class diagram. Okay, so just now I mentioned that analysis class diagram will have entity classes or domain classes. These classes actually responsible to store information. That's all, nothing else. So next I'm going to show you. Okay, yeah, all right. Now, design, when it comes to talking about classes, and there are many types of classes, okay, categories of classes, all right. Some classes are used to store information, data, like what just now I mentioned, entity class. Entity class means it's a class that actually is used to store data, that's all, okay. Um, we also have, let me show you this, okay. So over here we have, yeah, all right. Okay, so we also have classes that we call, right. I just want to remember, just like I mentioned, entity class, all right. We also have a class that is called flow, right, and then life cycle, okay, control, boundary, okay, utility class, user interface class, and so on, right. These are the categories of classes. So this one already mentioned. Okay, so the design class diagram, right, will have everything. All right, you will have entity class, you may have lifecycle class, you may have flow class, you may have utility class, you may have user interface class, you may have persistent class, and so on, right? Okay, so for every entity class, there is a controller, right? And the type of class is life cycle. Okay, life cycle, right, means that this class, right, is controlling another class. So for example, like user, all right, you have a user class, right? So user class is an entity class. You have a name, ID, and those kind of things, right? And for each entity class, right, there must be a controller. All right, and this controller, right, comes under this category. We call it lifecycle because this is the controller, right, a class that actually determines or creates object of entity class. So that's why we call it lifecycle controls. All right, so all the accrued operations, right, will take place here, the controller, right. So the controller actually manage the entity class, add, update, delete, everything, right, should be in the controller. All right, so if you have 5 domain classes or 5 entity classes, basically you have 5 controllers. One entity class is associated with one particular controller. Okay, so let's look at here, right, some of the examples. Okay, all right, so let's look at here. Yeah, all right, can you see that this is a patient class, is an entity class. All right, you have getters, setters, attributes, and everything, right, and you have a patient manager. So this can be called as controller, right, because this person actually control the entity class. So we call it life cycle. All right, so all the CRUD operations, add, update, delete, should be here, not here, should be here. Okay, so this person controls this. Okay, all right, so we also have another class, right, that is called a class that actually, right, is responsible to get input and then sending output back to the client, right. So I will say that that class should belong to this, all right, this category, right. Let me, yeah, okay, I will call it user interface, boundary, right? Boundary, okay, boundary, right? So this class, right, kind of class, right, is responsible to get input and then sending output back to the client. That's all right. So you can have a, so this kind of a class, right, normally is connected to the controller first, and this controller connected to the entity class. That's it. Okay. We can also have the flow. When you have the flow, right, the flow means, right, it's a class that actually is responsible to send data, all right, from the front end to the back end, right? Okay, so probably, right, you have a boundary class that actually accepts input, okay, and this class will communicate with the flow. The flow is responsible, right, to take the input from the boundary class and send to the controller. And the controller, right, will communicate with the entity class, right? So that's how it works. So if you look at here, can you see that user interface? This one, this class, takes the input, communicate directly with the actor, take in, and then will communicate with the flow class. This flow class, right, will pass the data, right, whoever actually, right, whichever class that actually needs the data, all right, that actually comes from the actor. So this person is responsible, right, to kind of like push the data, right, to whoever needs the data. Okay, so it's pushing to the lifecycle controllers, is pushing to utility class and other things, right? So this is how it look like, all right, when you put together everything. So your design class diagram, right, basically you have everything, all categories of classes, all right? Okay, let's look at here. Okay, so you have something like this. Yeah, all right. We have something like this, right? This is the class. Can you see that? This is the UI class or input output. This is the flow class. Can you see that it's connected to this? This is the design class diagram. Okay, design class diagram, right? So you have all the classes, types of classes, all right? So if you're developing an application based on object oriented, you will have all this compulsory to have. Okay, there'll be one class specialized on, getting input and displaying output back to the client. There is one Java class, or any, not necessarily Java class, it can be a class that probably we use C sharp or whatever things, right, that is responsible, right, to collect the data from here and then pass to the controller, right? So the controller, right, will do the update, delete, and so on. Okay, and this controls this, right? And of course, this class, right, is will be communicating with database, right, and communicating with another class, right? So that class, right, comes under this category. We call it persistent class. Where is it? Okay, persistence class. Yeah, this one, persistence, right? So you have a class that will communicate with database, right? So basically the controller will communicate with a boundary, persistence, right? So this class, right, we call it persistent or boundary class, right, will, will communicate with external source, right, storing data, pulling data, and so on, right? This boundary is communicating with the actor. This one is backend, right? So this is how you're supposed to develop, all right? When you develop an application, you must have design class diagram, right? Or you need to see the whole, the entire thing, right? Only then you can actually convert into codes. Then you know how many classes you have to build, what are the attributes, what are the methods. So design class diagram, right? Everything must be fully specified. All the attributes, all the methods and everything, right? Because only through that way, right, you can actually convert into codes. You know how to create a class, how you need to know what are the attributes in a class, what are the methods, and so on, right? Having done all those things, the next will be the sequence diagram. So sequence diagram, right, you have two types as well. You have sequence analysis, and then you have sequence design as well. Design sequence diagram, you have analysis sequence diagram. Analysis sequence diagram match analysis class diagram, and then you have design sequence diagram matching design class diagram. Okay, so basically sequence diagram is to show the interactions between classes. Okay, so that is the purpose. Okay, and after that, right, design, you may have a state chart diagram, okay, package diagram, and so on, right? So I will say that the important diagrams is up to, like, a sequence diagram. Okay, we need to know the interactions, and then design class diagram is important, analysis class diagram is important, use case diagram important as well, right? And of course, activity diagram to show what exactly happening, right, in each use case. That is very, very important, because later on we will create some methods. Every use case, right, is actually kind of translated into methods. You need to know, right, what exactly is happening inside, because later on when you convert into codes, we need to know the steps, all right? Step number one, number two, and so on, right? So this is how you develop an application if you have chosen object-oriented way, right? So structured way, I already mentioned, structured chart, GFT, you can actually just have one use case diagram. That's it. Okay. And so that's it. All right. So you need to have this knowledge, all this knowledge, right, in order to develop, okay, diagrams effectively, and thereafter, right, mapping into codes. All right. Okay. Um, so all these are important, all right, relationships and everything, right? Okay. So I hope actually, right, you have understood, okay, the diagrams that are actually important, all right, for system development, based either structured way or object-oriented way, right? Okay. All right. So that's it. Thank you for listening. Um, Take care. Right.